Hello people, my name is Jeff and welcome to my channel. Right from the start, a brief disclaimer. This is not just another YouTube tutorial on how you can use ChatGPT alongside various other third-party tooling to establish a faceless YouTube channel. Instead, in this video, we are going to discuss and actually do code how we can utilize AI, particularly large language models like ChatGPT. In fact, it can be any other large language model, including open source ones, to create our own custom YouTube AI assistant. This newly created AI assistant will act as a kind of a YouTube researcher, which has a great potential to help YouTube creators by answering their question. For example, analyzing YouTube or Google Trends, gathering statistics about the channels, comparing them, searching additional information on the internet. Maybe even help YouTube creators to find their YouTube niche or help with the first video ideas. Okay, so when OpenAI released ChatGPT to the public, suddenly YouTube was flooded with this kind of videos. How to start YouTube automation or how to start a faceless YouTube channel in 2024. In this video, people trying to explain how to use ChatGPT along with a few other usually paid services to start your own faceless YouTube channel. As you can understand, the main goal of all these videos is to do less but earn more, automate thing, which is sad because it will naturally reduce amount of unique content on YouTube, but that's what we usually want. However, we're here not for the money, but for the technology. And by the way, this is Dennis Ritchie, who represents technology on his own, and you should know this guy because you can find his work almost everywhere. Please give your respect to the author of C language. Okay, but let's get back to our YouTube AI assistant. At the end of the day, YouTube creators still want to choose their channel's niche and think about what videos and on what topic they will create. Of course, they can go to ChatGPT and simply ask to generate the best and most catchy video ideas. But we would like to do it in a more efficient and most probably clever way. Let's say I'm planning to start YouTube channel about AI, which I did. And what if I have some sort of AI assistant which I can easily ask, what are the best and most popular AI channel on YouTube in 2024? Since these channels are popular and successful, their authors likely know what they're doing. So I can easily pick one to ask my AI assistant again to generate video ideas not yet covered by this chosen channel, but are within the scope and theme of the channel, and of course have great potential to be popular and attract larger audience to my own channel. Or I can even ask what niche I should choose for my new channel based on the YouTube or Google Trends or Google search, whatever. This is interesting, and that's what we are going to code in this video. Okay, so our custom YouTube AI assistant will consist of three agents. The first one represents YouTube creator, the second one the YouTube research manager, which represents creator needs and guide the process of research or investigation as well as give constructive feedback to the third agent, which is YouTube researcher itself. Creator proxy agent will be also used for Python execution, while researcher will have access to our custom set of tools, each of which will be registered with LLM call as an OpenAI function. If you don't know what OpenAI function is, well, basically the latest OpenAI models are fine-tuned to be able to detect when the function should be called from the list of all registered functions. When the model decides to call a function, the JSON object is produced, which contains the name of the function and the parameters to call the function with. So our agent will collaborate with each other to eventually satisfy YouTube creators' needs. Collaboration or cooperative work of our agent can be used to simulate so-called system-to thinking of our YouTube AI assistant. If you don't know what system-to thinking is, so basically it's all about what parts of your brain are involved in the thinking process. In System 1 thinking, you don't have to think at all. And if someone asks you a question, you just basically return the cached information. So if I ask you what is 2 plus 2, then actually you're not doing this math. You just return me the cached answer. If you use System 2 thinking, then you don't have a cached answer. That's why your thinking process can take much longer, because you have to reason with yourself and try to think more rationally. If you want to get more insights on this topic, I strongly suggest you to watch the video by Andrei Karpathy, Intro to Large Language Models, where he describes in much more details what a system to thinking is. In fact, I strongly encourage you to watch all videos on his channel if you want to know in details how large language models work. So our custom YouTube AI assistant code will heavily rely on two main libraries, the Autogen and the Langchain. The Autogen will simplify communication between our agents and has a great amount of built-in patterns how you can structure your agents' collaboration in order to solve complex tasks. And as usual, I suggest you to look through Autogen examples and how they manage to solve really complex tasks by applying system to thinking and the collaborative agents approach. And by the way, as a side note, before Autogen or similar libraries became available, the community go-to approach was to use two main patterns, React prompting and communicative agents for mind exploration of large language models, or simply Camel approach. These two are quite interesting things to read. And if you want me to cover these two in more details, just leave the comment below. Okay, so I guess code speaks more than words, so let's start our custom YouTube AI assistant implementation. Alright, so we are inside our Visual Studio Code. We have our empty YouTube AI assistant solution open, and what we want to do first is to define our agents. Before doing that, we must add the Autogen library to our solution. So I will switch to the terminal and add Autogen package to my virtual environment. So I will write python -m, which stands for the module pip install pyautogen, which is the name of the Autogen package. And then I click enter. Okay, so the Autogen library is successfully installed to our solution. And now we will put our focus on creating our collaborative agents. As we discussed before, we will have three agents. So I go and create the main script for our application, which will be app.py. And here we will create all our agents, and we will start with the first one, which is YouTube Creator Proxy. So we will import the user proxy agent class from the Autogen library, and then we will use this class in order to create our YouTube Creator Proxy agents instance. Basically, we will pass the name of the agent, which is yCreator, and then the code execution config. As I already mentioned, our YouTube Creator Proxy will be also used for Python code execution. So we need to configure where and how this code will be executed by the agent, and that's what we can define in the code execution config section. In our case, we will simply execute Python code in the sandbox, which will be our local folder named code runtime sandbox, and then we won't run our code inside a Docker container, even though the Autogen library supports it. Okay, let me explain why we need this code execution at all. The thing is that our YouTube researcher agent will have access to our custom set of tools, which we will define a bit later. And when it decides to call a tool, which will be registered as an openai function, the actual execution of this tool, basically running the Python code, will be performed by the YouTube Creator Proxy agent, and then the execution results will be returned to the researcher back, so it continues its investigation. After looking through Autogen examples and how they create research collaborative agents, I noted that they actually separate agents, and they have one agent which represents human and basically allow them to control or guide the research or investigation process. In our case, it can be YouTube Creator Proxy, and another agent which is purely dedicated for the Python code execution. I suggest we will do the same in our code. Okay, so in order to extract code execution so it can be executed by a separate agent, we can go and create a copy of our YouTube Creator Proxy agent, like this. Then we rename the variable. Let's name it code executor. Then we also would like to change the name of the agent so we can identify the agent in our communication flow. And as soon as the code executor will be still used for Python code execution, so we can keep code execution config section in place. Another parameter which I want to change for our code executor agent is to change his human input mode and set it to never. If you look at user proxy agent class documentation, you will see that by default the agent will prompt for human input every time a message is received. For our code executor agent, we don't want such default behavior. But what we really want is to take our code, our Python code, execute it, and then return the execution results to our YouTube researcher so it can continue the investigation. Basically, we don't want user to be allowed to intercept our agent. Now let's get back to our YouTube creator proxy agent. As soon as the code execution was extracted into the separate agent, we don't need code execution config anymore, so let's set it to false. I would also want to change human input mode parameter and set it to terminate. Human input mode equals to terminate means that the agent will prompt human for the input only when the termination condition is met. In our case of investigation, the termination condition will be met when the investigation is completed. Or to be more precise, when the researcher manager decides that the researcher agent gathered enough information to produce fact-based answer to the creator's questions. In this case, a researcher manager will add word terminate to the produced research results content. We will see how to do it just in a moment. And this will trigger creator proxy to prompt creator for the feedback, so it can analyze the result, and if creator is not satisfied with it, then it can guide research manager to the right path to repeat the investigation. YouTube creator proxy agent needs a way to understand that the termination condition is met. This can be done by setting isTermination message delegate. We will provide lambda expression to it. The lambda expression will analyze content of the received message and will determine if it ends with the word terminate. If it's so, then the agent will prompt human for the input. Okay, so let's create our YouTube Research Manager agent as well as YouTube Researcher agent. In order to do this, we will use Assistant Agent class from Autogen library. The Assistant Agent class is designed to use LLM for solving tasks, which is opposite from User Proxy Agent class, which represents human-in-the-loop agents. So in order to create the rest of our agents, we have to provide LLM config to each of them. So let's go and create configuration file to store all our LLM's configuration. I will name it openai config list. That's basically the name which is used by the Autogen. And then I put here configuration for all my models I am planning to use. For this particular demo, I am using GPT-4 model from OpenAI, which is hosted on Azure. If you are planning to use OpenAI models directly, then I guess the configuration will be slightly different, but you can go to Autogen documentation and check how to configure it. The next step is to import helper function config list from JSON from Autogen library, and then use this function in order to read our configuration and then construct LLM config object itself. You can pass additional parameters like timeout or cache seed, which is used for caching your request response, which can potentially save you quite a lot of money while you're communicating with your LLM, or temperature of your models. But as I said, you can check all parameters in the Autogen documentation. So we define our LLM config and then pass it to each of our agent. And then the next step for us will be define roles to each of our agent. And to do that, I will create a separate file. I will name it prompts.py. And here I will define all prompts which is needed for YouTube Research Manager agent as well as for YouTube Researcher agent. Okay, so here we have our system prompts. I won't go and read it for you because I guess you can find all the code on my GitHub, so just find time and read it by yourself. But there are some key points which I would like to highlight. So YouTube Researcher agent is just a regular researcher. My idea was to control what researcher can do and how it can do it by providing it with different kinds and count of toolsets. All the rest is just a generic guidelines for any researcher. So researcher should search information on the internet, it should scrape the data from the URLs or links, and all the time it should think if it's enough information or if it can enhance the result of research. If it's so, then it needs more data to scrape or more search to do. That's it. On the other side, the YouTube Researcher Manager agent is a specialized manager for YouTube research. The agent should generate a research plan, which the researcher can execute and always push back to find as much relevant information as possible to answer the creator's question. The last thing I would like to highlight is the termination condition. If you look at the completion confirmation of our YouTube Researcher Manager prompt, you will see that the agent have to confirm the successful conclusion of the inquiry with the comprehensive fact-based answer to YouTube creator's question by stating terminate word. And this what we use when we check termination condition in isTermination message lambda expression. So we check if content of the received message ends with the word terminate. And that's how our YouTube creator proxy prompt human for the feedback. Okay, so we have our agents ready. So let's go and, for example, check that our research manager can produce the valid research result. So I will write creator proxy, initiate chat with a YouTube researcher manager agent, and then pass him a message. Let's say I would like to know what niche I should choose for my YouTube channel in 2024. I want it to be unique. Let's run this code and see what result it will produce. Okay, as you can see, the YouTube Research Manager was able to generate the research plan for the researcher. So basically, the researcher should begin by identifying the current popular niches on YouTube, and then it said how it can be done. This can be done by analyzing trends, user behavior, and market research reports from the sources like Google Trends, Statista, and YouTube's own trend reports. I don't even know what a Statista means. Then it also suggests to explore emerging technologies, social trends, and global issues that could influence new niches. Okay, anyhow, we have our research plan, which can be passed to our researcher to do the actual work. So I suggest we move forward and create our group chat for our agent collaboration. In order to create our group chat, basically the sandbox where all our agents will collaborate with each other in order to do the research and provide meaningful answer to YouTube creator question, we will use two classes from Autogen library, the group chat and the group chat manager. The group chat manager itself is the supervisor for our group chat. He is the one who controls the message flow between our agents. He can decide what agent should speak first and what agent should speak next. In order to make this decision possible, we will feed our LLM config to our group chat manager. So our GPT-4 model is available for group chat manager in order to make his decision. We also want to help our group chat manager to choose the right agent. So we will provide a short description to each of our agents. So let's find our YouTube creator proxy agent and set a short description. So description will be really simple. So we basically state that this is a YouTube content creator. Let's do the same for our YouTube research manager. Description will be a bit longer. So we said this is a research manager, takes creator's question and start guiding the process of the research to produce the fact-based answer. The last description we want to provide for our YouTube research agent. So we said this is researcher, it can research on any given topic. This agent's descriptions will be passed to GPT-4 model, which will be used by group chat manager under the hood to decide what agent should continue the conversation. Okay, so we are done with our agents, our group chat and our group chat manager. So now let's continue with our custom toolset. For our YouTube AI assistant, I suggest we implement the following toolset. First, we need the function which can perform the Google search for any given query. Then we would like to have a function which will scrape content from the page which was found by the Google search. So we have to implement scrape page content function. The following three functions will fetch data from the Google Trends. So we are interested in average interest over time for any provided keyword, related topics, as well as related queries. The next function is fetch YouTube trends, which will fetch trends from the YouTube itself. We would also like to have a function will fetch YouTube channel and video statistics by the provided channel ID. So let's implement all discussed functions one by one. Our Google search function is relatively simple. We will use search function from the Google search Python package. We have to provide the topic or query to perform the Google search on, then perform some mapping and just return the result. The most important aspects here are these two decorators. The first one, code executor.register for execution, registering our Google search function to be executed by our code executor agent. And that's precisely what we discussed before. Our code executor agent will be responsible to execute our Python code and return the execution results back. In order to help our YouTube researcher to understand the purpose of the function, or to be more precise, we want our GPT-4 model to understand the purpose of our Google search function, as well as correspond OpenAI function schema, we have to provide the name of the function, which is Google search, and then the description of our function, which is performs a Google search for the given query. We also have to annotate each input parameter of our function. We will use the same decorators for all our tools. The only difference will be the name of the function description, and then the annotation of input parameters. The next function is the scrape page content, which will scrape the content of the page which was found during the Google search process. So we will pass the URL to the function, the URL of the page we want to scrape, and then the reason why we want to scrape. We will see in a minute why we need this reason. And then I try to describe how the function works. So we will write browser in the headless mode, then we navigate our browser to the URL we want to scrape, and then we get the content of the page, which will be the HTML content. And then we use another library, which is Beautiful Soup, in order to perform some cleanup. So we will remove script and style tags, and then we get the text of the page. Obviously, the scraped text of our page can be much longer than the content size of our GPT-4 model. That's why I wrote summarize scraped content function. The summarize scraped content function is using Langchain library under the hood. The Langchain library is de facto standard for every LLM app. I won't go into much details how summarize scraped content function works. I encourage you to go and read more about Langchain library first, but just to give you the basic understanding. First, we would like to split our content into the documents. To do that, we will use text splitter from the Langchain library. Recursive character text splitter. We will provide the size of our document, and then the document overlap size, and then the separator. When we have our document splitted, then we will import summarization chain from Langchain library. The summarization chain will use large language model under the hood to perform the summarization. So let's go and create our large language model. We will use Azure Chat OpenAI class from the Langchain. We will provide parameters to this class from our .env file. As you can see, I am using GPT 3.5 Turbo model for our summarization task. I guess it should be quite enough for the summarization. Then we will switch our summarization chain into MapReduce mode, which will generate summaries for each of our documents first, and then it will try to generate the final summary from the summaries generated before. We will also provide summarization prompt to our chain. The summarization prompt is quite simple. Generate detailed summary of the following text tailored to the provided reason. And the reason is the reason why we're scraping the text and why we're actually doing the summarization. Be structured and do not miss any relevant details. Then we provide the reason and then we provide the text. That's it. We invoke the chain and then we return the result of the summarization. The functions fetching Google Trends data are quite similar, so I won't go into much details. First, I tried to use Python package PyTrends in order to implement all the three functions. Unfortunately, Google was throttling all my requests, so I decided to switch and use Serper API. The Serper API is not free, but I guess they have 100 requests for you to try. The logic of all the functions is quite similar. Basically, you define what data type and for what period of time you would like to fetch from Google Trends. For example, it can be time series, which is average interest over time, or related topics. And then you use SERP API client to fetch this data, and then you just simply return it to the agent. That's basically it. For Serper API client, you have to provide your Serper API key, but this value you can fetch from the SERP API web page. For fetch YouTube trends and fetch YouTube channel and video statistics function, we will use Google API client Python package. You have to generate developer key in your Google Cloud Console as well as add YouTube data API to your application. Fetch YouTube trends implementation is quite simple. First we search videos for all our keywords, then we fetch video IDs, and then we get statistics for each of the video, like title, view count, and like count, and then we return the result. To fetch YouTube channel and video statistic, first we check if the provided channel identifier is the channel ID or the username. Then we get channel information and basically construct channel details, like title, description, view count, subscriber count, and so on. And then we iterate all the videos in the channel and basically construct the same statistics as we did already before. So we extract title, view count, like count, and so on. Then we form the result and return it to our agent. All our tools implementation can be considered as a technical details. That's why I don't want to spend a lot of time on it. But you can go on my GitHub, and if you need more time to understand how the code for our tools works, just go ahead and check it. Okay, so finally, all our agents are set up as well as the tools, so we can go and try to test our YouTube AI assistant. So I will write YouTube creator proxy, initiate chat with our supervisor or chat manager, and then I will simply pass the same question I already did. What niche should I choose for my YouTube channel in 2024? I want it to be unique. Let's execute it and see how our YouTube AI assistant will reply to it. Okay, so let's have a look at the result, what our YouTube AI assistant was able to produce. So after YouTube creator sent his initial request, the YouTube researcher manager generated the action plan for the researcher. Basically, it guides the researcher to start with analyzing the current trends on YouTube, identifying the emerging niches that are gaining popularity, and predict their potential growth by 2024. And then YouTube researchers start the research process. It started with the Google search, basically searching for emerging YouTube niches in 2023. And actually it's quite interesting because it seems that it's hallucinate the year. But actually, if you look at the YouTube researcher action plan, so it asks researcher to predict their potential growth by 2024. So the researcher started to look at the emerging YouTube niches in 2023. So it can be quite logical, but I guess the takeaway in this situation is that our group chat needs another agent which can criticize decisions of YouTube researcher as well as YouTube researcher manager. In fact, if you think about it, all this community attempts to produce something useful with collaborative agents sooner or later will crystallize in set of patterns. For example, you can have a pattern which works really well when you need to do the research on the internet. So you will have a set of predefined agents with their roles. So what is left for you to do is just to put a bit of flavor in all this pattern by providing custom prompts. Prompts and tooling, of course. I guess actually Langchain already started to do that. They have a repository of the prompts which actually are really good in solving one specific problem. Okay, but let's get back to our research process. So after YouTube researcher suggests to call a Google search tool, code executor agent executed and returned the execution result, which is set of links found by the Google. Then YouTube researcher decided to scrape page content from the first link returned by the Google search. It provides the reason why it needs to scrape it, which is to identify the most profitable YouTube niches in 2023. And our code executor again executes scrape page content function, but in this case it actually did the summarization with the Langchain as well. Based on the summarization, our YouTube researcher decided to check average interest over time from the Google Trends. Basically, he passed the topic from the summarized article as the keywords. So first it checks for personal finance and investing, health and wellness, sustainable living, and so on. Our code executor, as usual, execute the function and then provided the execution result back. So basically it returns Google Trends for each of the topic. For example, for personal finance and investing, for health and wellness, for sustainable living. I won't go through the full research process, but let's have a look at the final result. So YouTube researcher come up with such conclusion. Based on the research, the most profitable YouTube niches in 2023 are personal finance and investing, health and wellness, sustainable living, and eco-friendly practices. This is actually a really good one because I never heard that we have such niche on the YouTube. At least I never see channels like this which are focusing on this niche. However, the Google Trends data show that the health and wellness niche has the highest average interest over time among these niches. This niche has been a growing focus on self-care with content related to physical, mental, and emotional health. The actually interesting fact here, which I like, considering the uniqueness factor, the sustainable living niche could be a potential choice as it's currently underrepresented but has a potential audience to the global push for sustainability and environmental concerns. And then our YouTube researcher manager mentioned that therefore, based on the current trends and future prediction, you could consider starting a YouTube channel in health and wellness or a sustainable living niche for uniqueness and potential growth by 2024. However, the final decision should align with your interest and expertise. I guess that's basically what we need. I encourage you to pull the code from my GitHub and try it yourself, or maybe even enhance it. If you get better result, please share it with me. I will be really interested how you did it. And I guess this can conclude our video. Thank you for watching and see you next time. Bye.